let's look at the reactions of chromium. So I'm going to look at about four types of reaction. That's with air, specifically oxygen. There is water, acids, where we shall have dilute and conc acids. So here we shall have dilute as well as the conc acids. And then finally we shall look at reaction with chlorine. Let me try to reduce this. So reaction with chlorine and hydrogen chloride gas. So to start with water, to start with air. So we have already seen that chromium at room temperature, it normally has a protective coat of the chromium 3 oxide. That's the protective coat that's formed normally at room temperature, which means that this would normally hinder its reaction with other elements or molecules. However, for it to react with oxygen, this chromium uh, should be heated. The chromium should be heated. Let me just take away this so that doesn't distract us. So this chromium should be heated at a temperature of around 2000 degrees Celsius. At around 2000 degrees Celsius. So it should be heated at around that temperature so that we can have a reaction between the chromium and oxygen. In other words, you'll find some books just saying that heated chromium reacts with oxygen to form then the resulting compound. So what will it form? It will form compounds in its most stable oxidation state, that is the plus 3. Okay? So we shall have chromium reacting. Let me increase the size so that we get to see this well. So we shall have chromium reacting, this is a solid, reacting with oxygen, that is a gas. Always be very careful when you're writing these symbols. I'm trying to show the right way of writing these. So reacts with oxygen to form chromium 3 oxide. So I'm assuming that someone who didn't know how to write the chromium 3 oxide. So how shall I write this? I know that my chromium will be in oxidation state 3, and then my oxygen will be in oxidation state 2. You get? So how will I balance these charges? I'll have a 3 here and I'll have a 2 on chromium to make the total charge 6 so that they cancel out. In other words, I'll have 2 chromium, 2 chromium, and then 3 oxygen atoms. And this is a solid. So I can actually balance this by having this oxygen multiplied by a 3 this side, and then or let me try to use an easier way. So how am I going to balance this equation? I can look at the chromium first. Chromium, this side I have 1, this side I have 2. So how do I balance this? I can multiply by a 2 here. You get? So I'll have the chromium balanced. However, the oxygen is not balanced in that this side I have 2. Let me try to use different colors. In that this side I have 2, but on the right hand side I have 3. So how will I balance this? You can see that I can actually multiply this side by a 2 and then this side by a 3. However, if I do so, I'll be affecting the chromium, which means that I'll have to erase the 2 away, you get? And in this case, oxygen will be a determinant of the value that will be attached to the chromium on the left-hand side. So if I multiply by a 2 here, that will make the oxygen atom 6, then this side by a 3 to make it 6 as well. So oxygen is determining the number of chromium atoms that I must use. So this side there will be 4 oxygen atoms. So that's how I balance that particular equation, and that's the reaction with air. So here I'm going to include the temperature. You may not necessarily include it in your equations, but I'm just putting it as a point of emphasis. 2000 degrees Celsius. So that's the temperature at which this reaction normally occurs. So you can say that heated chromium reacts with oxygen to form chromium 3 oxide, as simple as that. Then we can look at the reaction with water. So how will chromium react with water? So still, chromium will not react with cold water. You get? In other words, we shall need something like heat. And of course, when we introduce this heat, we don't expect our water to remain as drops or what, but in other words, it will turn into vapor. Get? And that vapor, we can actually call it the heated water will, in other words, form what we call steam. That is the gaseous form. So, in other words, the chromium will react with steam. You get? So that's the reaction that will occur. And what will it form? It will form chromium 3 oxide and hydrogen gas. That will show that the reaction actually occurred. So here I'll have chromium reacting with a steam because it will not react with cold water. So there must be heat which changes this water to steam. So I have chromium reacting with steam, and then these are going to give me chromium 3 oxide, which I've already showed you how we get to this formula of the compound. So we have our O3, a solid, and then hydrogen gas, which is a gas. So we have hydrogen as well. Hydrogen gas. So now when it comes to balancing, this is where most students find it very hard. But I personally used to enjoy the balancing part for one reason, in that I used to practice these equations, so everything was just obvious to me. Okay? So I encourage you that after doing it the first time, always do it and do it and do it and do it again and again. It will eventually become part of you. So let's try balancing this. What shall we start with? We can start with chromium. So this side I can put a 2. I'm assuming that I don't know. So I'm just using a pencil for the first time because I don't know what to use. Then the chromium will be balanced. I can move on to hydrogen. Hydrogen, this side we have 2. And then this side we have 2 as well. Then what of the oxygen? Oxygen, this side we have 3. And on the left hand side we have 1. Which means that actually oxygen now is going to dictate what I'll have as the value of hydrogen. Why? Because if I'm to multiply this side by a 3, it will directly affect the number of hydrogen atoms. So I'll have my 3 here, and that will change the total hydrogen atoms to 6, which means that I have to include here my 3 to balance the hydrogen atoms as well. And I will have my equation balanced in that manner. So that's the reaction with water. This is gaseous form, which is steam. Get? And here we say the condition was that the chromium should be heated. You may not be specific about the temperature, but you have to show that it's heated. And then here the condition is that you have steam reacting with the chromium. So that's it basically for the part of water. And we can look at the next part, which is reaction with acids. So I will try to erase this and have enough space. So now reaction with acids, we need to take note that uh, this chromium will only react with two acids 3 times. You get? So there are two acids it will react with, and it will react 3 times. This may not make sense, but here you're going to get the sense now. So what I mean is that we have dilute acids, and we also have concentrated acids. So we have concentrated. So what I mean by 3 times is that you can have 2 times this side and only 1 time this side. So that's like a trick I used to remember whenever it comes to reactions of chromium with acids. So I remember that it only reacts with two dilute acids and then with one concentrated acid. So that the acids we know, the common ones are hydrochloric acid, we have sulfuric acid or sulfuric, and then we have nitric acid. Nitric acid. So nitric acid, we know it well that it's a strong oxidizing agent. However, it will not react with this chromium, whether in dilute or concentrated. So we cut out the nitric acid, and meaning the dilute acids that it react with will be dilute hydrogen, I mean dilute hydrochloric acid and dilute sulfuric acid. So here we shall have HCl, and we shall also have the sulfuric acid in their dilute forms. And then what of this side? It will only react with concentrated sulfuric acid. So that's what I meant by it reacts with two acids 3 times. That's what I meant. So here we can look at the equations. So what will happen is that the chromium in its atom has an overall charge of 0, you get? And what will happen is that it will be uh, oxidized to +2, you get? It will be oxidized to its +2, that is oxidation state of +2 by these dilute acids, you get? I'm just giving an explanation behind. So from 0, it will be oxidized to the +2 because these are weak acids, you get? However, when it's reacting with concentrated acids, you'll find that it will be oxidized to +3 form because this is a concentrated acid, you get? So it will have more oxidizing power than the dilute acid itself. So what happens is that the chromium will react with these acids to form chromium 2 ions or chromium 2 salts and hydrogen gas. However, what will happen is that due to the oxygen that will come in from the atmosphere, it will oxidize these iron to ions, I mean the chromium to ions, to chromium 3 ions. So that's the trick behind. So you will have a blue solution because chromium 2 in solution actually appears blue, then the chromium 3 appears green. So when this reaction occurs, you will form a blue solution which on standing turns to green, but most cases this reaction occurs rapidly because oxygen cannot wait, it's always there in the atmosphere. So in our explanation, we can say that chromium reacts with maybe dilutes hydrochloric acid to form chromium 2 chloride and hydrogen gas. Then we can go on and say that the chromium 2 chloride salt formed is rapidly oxidized by the atmospheric oxygen to form chromium 3 chloride. You get? So I'll write the equation here. My space is not enough, but I will try to squeeze it here. Let me use a bit a different color. So I have chromium plus hydrogen chloride, and then I have my aqueous, and chromium here is a salt, I mean a solid. So what will they form? Shall have, I'll erase this, shall have our chromium 2 chloride. How are we going to write this formula? I'll come back here and show you the basic. I'm doing this just for the first time. So we have our chromium, which is going to be in the +2 oxidation state, then the chloride is in the -1 or 1 minus. So which means that I must have 2 chloride ions to balance this equation. So I should have 2 chloride ions. So this will be a chromium, then the chloride, but 2 of them. And this is aqueous, plus hydrogen gas, because I only have hydrogen on the left hand side. So hydrogen gas. How am I going to balance? You can see that I have 2 chloride, 2 hydrogen. Just come and put a 2 here, and you have your equation well balanced. So that's it for the chromium chloride. Then how about the sulfate? So for the sulfate, I can have my this sulfate. This is in aqueous. I'll erase this as well. So this will give me in the +2. So how am I going to try this? I'll also show you because it's the first time we are writing it. I have my chromium here, which is going to be in the +2 because this is a dilute acid, and then the sulfate, which is actually written like that. So do I need to multiply anything? No, because the charges are the same. So I'll just have one sulfate and one chromium atom. So I'll have my chromium, then the sulfate, aqueous, and then my hydrogen gas. Do I need to balance anything? Not really. Everything is well balanced. So this is the reaction that occurs with dilute acids. However, we can also have an overall equation which can be written as Cr which is a solid reacting with hydrogen ions which are from the dilute acids, and this will give us chromium 2 ions and hydrogen gas. So you can go on to balance this equation. You see that the charge or the hydrogen atoms are 2, and here this side I have 1, so I put here 2. If I put a 2, you can see that everything will just balance. This is very easy to balance. 2 hydrogens, 2 hydrogen. The charge plus 2 plus 2. Chromium 1, and that's well balanced. Don't forget that all states must be included. This is aqueous. Of course, you cannot have solid ions. They will always be in aqueous form. So this is like the overall equation you can have under the dilute. So coming to the however part, which is the oxidation, we can say that these chromium 2 ions will rapidly be oxidized by atmospheric oxygen to form the chromium 3 ions. So we can try writing this equation as well. So we shall have, use a different color. You will have your chromium 2 ions. Let me use purple this time round. So you will have your chromium 2 ions being exposed to atmospheric oxygen. So these are in aqueous, as I said, chromium 2. And then I have my atmospheric oxygen. But also remember, in the solution there are hydrogen ions. You get? So they have not gone anywhere, but they are still in the solution. So what will turn out is that we shall have these being oxidized to the chromium 3 ions. And as I said, the transition will be from blue to green. Then what else shall we form? If I have oxygen and hydrogen ions, I always expect to have water as a product. And then we can balance our equation. So balancing this equation, there are two things we are going to look at. The first one is the charge, and then the second one is the number of atoms themselves. So I can start with chromium. Chromium itself is balanced. So this side I have 1, and this side I have 1. What of oxygen? This side I have 2, and this side I have 1. So how can I balance the oxygen? I'll need to put here a 2. But if I put here 2, I realize that it will be changing my number of hydrogen atoms to 4. You get? So I'll need to put here a 4. But again, if I put here a 4, it's now affecting my charge, which means that chromium will also have to now come in and balance my charge. So the trick is that if initially these charges were balancing, it means if I put any value here, I would have to put the same value here and the same value there. You get that trick? Because initially the charge was balancing, meaning if I multiplied here by a 4, I would also need to multiply here by a 4 and a 4 to remain with the same charge. So I just need to put here my 4 and this side a 4. So that's the trick behind balancing that equation. Because the charge was initially balancing. So any change to one part would require me to apply the same change to all. Ideally, if you count these, you will realize that actually everything is balancing, because if I have 8 plus 4, that is 12, then the 4 multiplied by 3, I get a total of 12. So just writing this properly, because this is not allowed, you're not supposed to put those like that. You're supposed to show everything in a straight line. So this is plus 4 balanced here. You get? So that's the however part where we have the oxidation of iron to ions, I mean the chromium to ions to chromium 3. Then now we can turn and look at the reaction with the concentrated acid. So I can erase most of these. So we have chromium reacting with concentrated sulfuric acid. So concentrated, ideally it's supposed to be in liquid form to show that there is no dilution of water. So I'll give it the standard form, which is a liquid and not aqueous as it appears in some books. So we have the sulfate, I mean the acid concentrated form, and that will give us, let me try to draw a short arrow, have enough space. So what do we expect from? We expect from a salt of chromium in the +3 oxidation state. So how will I write that salt? I'm assuming that I don't know how to write this salt. So I'll have my chromium, which I expect to be in the +3 state due to the strong oxidation, and then my sulfate, which will be the -2. So I'll just use the basic knowledge which we attained from our O level, in that the 3 comes this side and the 2 comes there. So I expect to have 2 chromium atoms and 3 sulfate molecules. So how will that be written? I'll have my chromium, which are 2, and my sulfate will be in a bracket. Why? Because I can't just put here 3, it wouldn't make sense. It would be like writing a 43. So I put this in brackets to show my sulfate, and there are 3. This is a soluble solute, so it will be the aqueous state. Let me move this slightly so that we have enough space. So what else will be formed? Normally for concentrated sulfuric acid, we also have sulfur dioxide as a gas coming off. So we shall have sulfur dioxide as a gas. So this is normally for concentrated form only. And then we shall have water as well, because we had hydrogen that side. So water as well. Now we come to the seemingly hectic part, which is the balancing part, which most people fear, but I will try to show you how easy this can be. So the first thing is balance chromium. This side I have 1, this side I have 2. What will I do? Let me first put here 2 to balance chromium. The moment I see that chromium is balanced, I move on to the next atom. What's the next atom? It's hydrogen. How many hydrogens do I have this side? I have 2, and on the right hand side I also have 2. So that's okay for now. What of sulfur? Sulfur I have 1, by this side I have 2. You get? So now I've seen the problem is with sulfur so far. And then I can also look at oxygen. How many do I have? I have 4 oxygen atoms. And then this side I have these are 12 plus 2, those are 14, then 15. You get? So there is no balance at all. How am I going to balance this? Actually, the sulfur are 4. I missed this out, sorry. Because of this 3 that multiplies this, and then plus 1, they are 4. So how am I going to balance this? I can use one of the atoms to based on in terms of my balancing. If I base on sulfur, what will I need? I'll need to have at least an even number. So if here I have 3 and here I have 1, how can I make this even? I can try using what nearest number can I multiply by this to have an even total? 3, I can add on 3, right? Because it's already 1, so I can't add 1. So the next I can add is 3. So if I add 3, I'll have 6 sulfur, 6 sulfur, and then decide I'll have to multiply with a 6. You get? But you can see that this is directly affecting the total number of hydrogen and oxygen. So even this side I'll have to multiply by a 6 to show the change in the hydrogen atoms. What of the oxygen? Oxygen this side are 24 and this side I have 12 plus 6, that is 18, then plus the other 6, that makes it 24, and the equation will be balanced. So many people used to wonder how I used to remember all these equations without referring to the book. The basic idea was not behind cramming, because that was the assumption for most people around me. But the idea was that I used to over practice these equations. You get? On a daily basis, I used to write an equation from transition elements, and not just one, but as many as possible for a given element. So the more you practice this, you find them like they are becoming part of you. I always emphasize that you try it out, and that's it for the concentrated acid and the acids at large. So we can look at now the reactions with chlorine and the hydrogen chloride. So now for the chlorine and the hydrogen chloride, they will have almost the same conditions, but they'll have different products. So in both, the chromium should be heated for reaction to occur. The chromium should be heated to have the reaction taking place. So it should be heated. And then uh, another condition is that whether it's chlorine or the hydrogen chloride, they should be dry. So you should have dry chlorine or hydrogen chloride. So they will be the same conditions, but we shall have different products. So for chlorine, it will form chromium 3 chloride. However, for hydrogen chloride, due to the fact that we form um, hydrogen gas as well on the side of products, we shall find that the hydrogen gas that's formed reduces these uh, chromium 3 ions to chromium 2 ions. Hence, for the reaction with hydrogen chloride, the product would be in the oxidation state of +2. So with that explanation, you should be able to write these equations on your own. So this one will just give us chromium in the +2 oxidation state. Why? Because the +3 that's formed initially, it's reduced by the hydrogen gas that's from this side back to the +2 oxidation states. So you can as well write for chromium with chlorine. You have a 2 here, and then you have a 3 on the chloride, on the chlorine, and a 2 on the chromium. So lastly, we shall look at the reaction with the alkali. With the alkali, it will still form products in the +3 oxidation state. So the alkali in this case, we are mainly talking about the hydroxide ions, which can be from sodium hydroxide, or we can also have potassium hydroxide. So I have my chromium here. Personally, I prefer ionic equations because they are a bit easier to balance, plus the hydroxide ions, which can be from sodium hydroxide. I mean from sodium hydroxide. So this will be aqueous. And then this side, we are going to form products in the +3. So there are 3 ways of forming this product. This product is called chromite. So this chromite, as we saw under nomenclature, it can be written in this form. This is what we call a chromite. So if you try to calculate the oxidation state, you will see that chromium will be in oxidation state 3. Or it can also be written as this form. It can also be written in this other form. Can have this, or can also be written as Cr or 2 minus. So these are the 3 different ways of writing chromite, that is the iron. So it means that if I'm to consider the first one, I'll have a C R OH OH 4 minus. Then which other product do I expect to have? I expect to have maybe hydrogen gas, in case the balancing doesn't work out, but you should be knowing that there is hydrogen gas. So if I try to balance this equation, you realize that chromium will be balanced, but oxygen and the hydrogen can never balance. Why? Because if I try putting here 4 to balance oxygen, I'll realize that hydrogen cannot actually balance. So what will I do in such a case? What I will do is that I'll have water on my left hand side. So in the first place, you may not know that it's there, but as you try to balance, you realize that everything is not working out. So that can be a clear indicator that among your reactants, you actually have water. So after introducing my water, I can balance again. So where am I starting from? Chromium is balanced. I can start from oxygen. Oxygen here I have, this side I have 2 and this side I have 4. So how can I make these 4? I have to multiply this side by 2. But how? Am I putting here 3? If not, am I putting here 2 and 2? If not that, what am I going to do exactly? Remember, whatever I do to this hydroxide will directly affect this value here. So if I put here a 2 and a 2 to balance oxygen, you can clearly see that this will change the value of the oxygen atoms, you get? So if I tried using a 3 here, and it would mean that I would also need to put a 3 again. So it would make no difference. In other words, That would mean that I can go for a 2 first to test. If I put here a 2, means I have to balance my charge also by 2. If I balance the charge, I realize that the oxygen on my right hand side are changing to 8. So how am I balancing this side? I can introduce a 6 to make this 8. 2 plus 6 oxygen, that will be 8. What of the hydrogens? They are the ones remaining. I have 2 plus 12, that's 14. And what of this side? I have this 8 and this plus this, it's 10. So how am I going to make this side also 14? I have to add 6. Where is the 6 coming from? Just multiply this by 3. And I'll have my equation well balanced. So you can as well try out the, the equation for that and that other product. You realize that almost everywhere you will have or you will need water. Then if I didn't want to use ions, I will just replace this ion with the sodium itself. In other words, this would be sodium hydroxide aqueous, and then this side I would have sodium chromate, sodium chromate, like that, and the hydrogen gas. But now when I'm explaining, if I'm to use an ionic, I'll say that chromium reacts with the aqueous, I mean the chromium reacts with the hydroxide ions from maybe the aqueous sodium hydroxide to form, what is this? To form chromite ions and hydrogen gas. If I wanted to use this other equation which includes the sodium, I would say that sodium reacts with sodium hydroxide, aqueous sodium hydroxide solution to form sodium chromite and hydrogen gas. That's how I would state my description before writing the equation. And then the other thing you need to take note of is that this reaction is actually slow. So you also need to incorporate that in your description, that chromium reacts slowly with the aqueous sodium hydroxide. And that's it with the alkali. So your assignment is try out writing that equation and balancing it as well as for that other equation and see how best you can do it. So that covers the reactions of chromium. So we can look at um, the compounds of chromium now in the different oxidation states in the next part.